Well, hi there. I'm Kira, and today we're gonna go over series and parallel circuits. So this is series and this is parallel, and we're gonna go over how to solve a few problems. But first, we're gonna go over Ohm's law, which I have right here. And for those of you who don't remember, it is voltage equals to current times resistance. I also have this helpful tip which I have seen in various videos, and it is basically just a pyramid that helps you remember these variations of Ohm's law. So if you're looking for voltage, cover V and you have current times resistance. If you want to find current, then you have voltage over resistance. If you want to find resistance, then you have voltage over current. So moving on to engineering notations, let's say I have this big number, it's 1550. I can make it into 1.55 kilo ohms, so K, which is 10 to the third power. So right here we have kilo, we have milli, and we have micro. And let's say I want to change this other number, it's a decimal, into milli. I can move my decimal 3 units down, so it would be 0.2 milli, or add 2 zeros and make it 200 micro. And that's all I wanted to cover before we move on to series circuits. So right here we have our series circuit, and we have our voltage and resistance, and we're trying to find the current. So how can we find the current? Well, we can find this formula from the variations we had previously seen. So right here we can cover I, and we have voltage over resistance. So I wrote again the formula right here, and that's all you need to find the current in this simple series circuit. And right here we have two voltage sources. This is just two variations of it, but they're basically the same. So we're moving on to the example of series circuit. And one question you can be asked for is to find the R equivalent. That's the equivalent resistance or total resistance in a circuit. So right here we have three different resistors, and it's a 10K, 20K, and 30K. So since they're connected in series, you can just add them together. You can do R1 plus R2 plus R3. So you can just combine these all, plug it into the calculator, and you will get 60 kilo ohms. Now on to finding the current, we can just do a simpler circuit. So like we had before right here, we can do replace all three resistors into just one resistor called R equivalent. So instead of having these three resistors, we would just have this one resistor, 60 kilo ohms, 3 volts, and we can just plug it into the formula and get 50 microamps. So moving on to finding the voltage across each resistor. Now each resistor here, R1, R2, and R3, will have the same current. This is because they're connected in series. So this current that we just found, 50 microamps, will be the same for R1, for R2, and for R3. So now that we have current and we have resistance of each resistor, we can find the voltage across each resistor through voltage equals to current times resistance. And once we find the voltage across each resistor, then we can prove KVL, but it's not necessary, it wasn't asked for in this problem. But if you add up all the voltages, you'll see that you get 3 volts, which is the same as the voltage source. And if you have any questions on Kirchhoff's voltage law, let me know down in the comments, and I would make sure to make videos about KVL or Kirchhoff's voltage law and explaining it more in detail. So moving on to simple parallel circuits. Here we have a very simple parallel circuit with two resistors R1 and R2 connected in parallel to 5-volt source. So we can find a equivalent current based on the equivalent resistance. And now the equivalent resistance is not gonna be the same as the series circuit. Now it's gonna be an inverse. So R1 inverse, R2 inverse, and all of it's gonna be inversed again. And now that we have our equivalent, we can plug in our values and find the equivalent current in the circuit. So we have 5 volts over 6.6 kilo ohms, and that is equal to 0.76 milliamps of current. That is our equivalent current in this circuit. So now moving on to the example of parallel circuit, another one we have right here, and now this one's a bit different. There are 3 resistors in this circuit, and there are 2 in this one branch, which looks a bit weird, but don't worry, it's still simple to solve. So we can just look at it with our 2 fingers covering the top branches, and we can see that they're both connected in parallel, just like if we look at the top. So now we can take these 2 parallel resistors and make them one resistor. So right here we're gonna have 5 volts, 20k, and now this combined would be 5k. So we have 20k, 5k, and now we're basically at the same circuit that we had before. And now we can find our equivalent just like before, which is equal to 4 kilo ohms. Now to find the current I1 and I2, we're gonna need something a bit different. Not this, but instead Kirchhoff's current law. Well, and what is Kirchhoff's current law, or KCL? Well, KCL is nothing more than just the sum of all the currents going into a node. In this case, this is my node. So any current going into the node will be positive, any current going away from the node will be negative. So let's say right here we have I, right? And it's going into the node. That's my node, the dot. So that would be positive. I1 is going away from the node, it would be negative. I2 is also going away from the node, therefore it's negative as well. So the sum of all of these currents should be equal to 0. We can solve for I by just moving I1 and I2 to the other side, which would change their signs. So now I is gonna be equal to I1 plus I2. So now we can find our currents. But there's also one more thing that you should know, and that is that the voltage across elements in parallel is the same. So this is 5 volts, this is also 5 volts. And the voltage drop across here is also 5 volts. So now that we know voltage and we have resistance, we can find the current going through each branch. So I1 is just 5 volts over 20 kilo ohms, which is equal to 0.25 milliamps. So the same thing for I2, our current I2 is 5 volts again over 5 kilo ohms, which is equal to 1 milliamp. So adding these 2 currents, I1 and I2, would give us an I of 1.25 milliamps. So that is all I have for you guys today. Thanks for watching. Bye.